Here are some examples of problems about translating trigonometric functions. Problem 1. State the vertical shift, phase shift, period, and amplitude of y equals cosine of x plus 5 and graph it. First of all, since we just have cosine of x, which is not multiplied by any factor, the amplitude is just going to be 1, since that's the amplitude of cosine of x. Next, the x that's inside of cosine of x is not multiplied by anything either, so the period for this function will be the same as the period as for cosine of x, and that's just 2 pi. Now for vertical shift, the shift will be 5, since we have cosine of x plus 5, which shifts it up by 5. And for phase shift, there is none, because we have cosine of x instead of cosine of x minus something, or plus something. Now let's graph this function. It's going to look exactly like cosine of x, except, as we just figured out, it will be shifted up by 5 units. So we'll have something like this. And on the other side, it'll be the same. So this point right here will be at 4, and this will be at 6. Since the amplitude is 1, but it should be centered about 5. And since the period is 2 pi, this will be at about pi, while here is minus pi. Problem 2. State the vertical shift, phase shift, period, and amplitude of y equals minus 3 plus tangent of x plus pi over 4 and graph it. Since the tangent function here will approach infinity or minus infinity at its asymptotes, the amplitude is undefined, or none. And for the period, the x that's inside of the tangent is not multiplied by any factor, so the period will be the same as the period for tangent by itself, and that is pi. Next, the vertical shift is going to be minus 3, since we have minus 3 plus the tangent function. And finally, the phase shift is going to be equal to minus pi over 4. This is because we have x plus pi over 4 in the tangent, so we should subtract, or rather multiply pi over 4 by minus 1 to get the phase. Now let's graph this function. So we're starting with a tangent function, and it's shifted down by 3, and to the left by pi over 4. So it'll look something like this, with asymptotes here and here, and this pattern will repeat a few times, like this. The middle point on each of these curves should correspond to a y value of minus 3, so plus 3 is about here. Then if we move one period right in the x direction from the origin, we find that this point is at pi, and then minus pi should be about here. Problem 3. State the vertical shift, phase shift, period, and amplitude of y equals 2 sine of 2 times x minus pi over 2, and graph it. We know that the amplitude of sine by itself is just 1, which means that multiplying the sine function by 2 will give us an amplitude of 2. For the period, we see that inside of the sine, x has a factor of 2 multiplied to it. This means we take the original period of sine, 2 pi, and divide it by absolute value of 2, and we just get pi. Now for the vertical shift, there should be none, since the sine function is not added to any constants, so we have 0. And for the phase shift, we have x minus pi over 2 inside of the sine. Even though it's multiplied by 2, this is still going to shift the function pi over 2 units to the right, and the phase shift is pi over 2. Now let's graph this function. So the function will look just like sine, except it'll go twice as high and twice as low. The period will be half of what it was before, and it'll be shifted by pi over 2 to the right. So we get something like this. And in the other direction, like this. The height of this will be 2, and it'll go down to minus 2. And the distance between here and here should be equal to the period, which is pi. So this should be minus pi over 2, and this should be pi over 2.